The law of cosines is the most complete way of solving for a triangle. And it's the most complete because it can solve the other two cases that the law of sines cannot. Side, angle, side, and side, side, side. This is the law of sines. So in a case where I'm given side, 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 I'm given A, B, and C. If I were to put this into the law of sines, I'd have sine A over something known, sine B over something known, and sine C over something known. But with these known factors being on the bottom of fractions, I will never be able to get some ratio where I can do a comparison. Where if I had one of these angles, A, B, or C, I'd be able to say, well, this is the ratio, multiply, I can get sine B, multiply, I can get sine C. But I can't do that. And it's the same for a side, angle, side, where I would have, say, A, B, and then angle C, where I would have something known on the bottom of this fraction, something known on the bottom of this fraction, and something known on the top of this fraction. But again, I don't have some ratio where I can make a comparison. So these two cases, I can't use the law of sines. And this is where the law of cosines comes into use. It's three formulas. And in most cases, if I want to solve for the entire triangle, well, in all cases really, if I want to solve for the entire triangle and I'm only given three pieces of information, then I'm going to have to use all of them. And it goes about something like this. So take a case, side, 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 for example. I would first put these numbers into any one of these formulas. It doesn't matter. What I'm really looking for in a side, side, side is these unknown angles, A, B, and C. I don't know any of the angles. So I look at these formulas, and each of these formulas will solve for one of the angles. This one has angle C in it, this one has angle B in it, this one has angle A in it. And for each of these formulas, the rest of these unknowns or variables are the sides. So what I would do is I would pick any one of these formulas. I know A, B, and C, I know all of these. So I would insert these numbers into these formulas, and then I would be able to solve for whichever one I put in. Suppose I did A first, this bottom one. I would put all the sides in, and then I would solve for cosine A. And then I would have angle A. And then I would do it for one of these other two. Let me say I just choose C. I would do the same thing, plug in all the sides, and then do the inverse cosine, and then I would get angle C. And then at that point, I could do the third formula if I wanted to, but why bother when I can just subtract from 180 and get the third angle? So that's how I would go about solving a side, side, side. And for a side, angle, side, it's very similar as well. But in this case, I would use whichever formula I had the angle. So let me say I had A, B, and then angle C. I would use this formula first because I have three pieces of information. I can't use this one because I don't know angle B, and I don't know side C. And this one I don't know side C either. So I would use this one. I have A and B, and I have angle C, so I would be able to solve for C squared. Once I know C squared, I can then take it as a side, side, side problem, where I now know side C. So then I solve for one of these remaining angles. I could use this formula or this formula, in which case I will be left with a second angle. If I did the second formula, I'm going to have angle B. If I did the third formula, I'm going to have angle A. And once I have a second angle, I can subtract and get the final angle.